So we are going to talk in this lesson about some piecewise functions here. We're going to talk about what those are and what they look like. Um, we're going to be able to analyze some piecewise functions here, and that involves looking at it and figuring out a lot of different things, as well as evaluating those piecewise functions. A piecewise function, first of all, to know what it is a function that is in pieces. That's why it's called that. Now, that's not very mathematical. What a piecewise function is usually two different functions that have been pieced together. So this one, for example, is part parabola and part line. You can see that on this left-hand side, you've got a line here. And then on this right-hand side, we've got the shape of a parabola. So there's two pieces that have been put together. A piecewise function is always kind of interesting because it changes and there's some sort of qualification or parameter put upon it. So for example, this you can see if you look at the function, we're looking at 2x plus 8 if x is less than or equal to negative 2. If x is greater than negative 2, the function becomes x squared. So when we're looking at a piecewise function, we have to be aware of the parameters of the domain to figure out which section of the graph that we're in. And that's what we're going to talk about a little bit more. So here we have a piecewise function, and we've got two parts here, okay? So we've got an x plus 5. That's for all values of x that are greater than 7. And we've got a negative 3x, and that's for all x values that are equal to or less than 7. So we've got to kind of split this into its two parts. The first part being when x is greater than 7, we would add 5 to that number. And when x is less than or equal to 7, we would multiply by negative 3. Now, pay very, very close attention to the number to see which one it falls into, because the 7 falls into this bottom one. So up to, but not including 7, or sorry, down to, because it's greater than, but not including 7, we're going to do x plus 5. Anything less than and also 7 will be plugged into this negative 3x function. You can evaluate a piecewise function for specific values, which is what we're going to do here, by simply plugging them in. It's kind of easy to do once you figure out which part you're looking at. So the first thing you want to do, this is telling me to find g of 5. So I want to find the value of 5 in the g of x function. First, I have to figure out which piece to plug it into. So I want to go over here and I want to say, okay, which of these is 5? Is 5 less than or equal to 1, or is 5 greater than 1? Well, clearly we know it's greater than 1, which means that I'm going to put 5 into the 3x plus 1 part. So I'm going to take 3 times 5 plus 1, which gives me 16. So g of 5 for this function is 16. Second, I'm being told to do g of negative 1, so I'm going to do the same thing and first figure out where is negative 1. Is negative 1 greater than 1 or less than or equal to 1? Obviously less than or equal to 1, so I'm going to plug it into the 2x minus 1. So I'm going to say 2 times negative 1 plus 1 is negative 1. So g of negative 1 is equal to negative 1. Not too terribly hard if you can figure out which part it applies to. So here we're being told to evaluate 3 different things. This might be a good point to stop the video and try this on your own and see where you can get. So I'm going to start with g of 0 here, and I have to figure out which of these 3 pieces, I'm going to label them. How about this? A, B, and C. Does g of 0 fit into? Well, 0 is a number between negative 2 and 1, so I'm going to use the B function to figure that out, which tells me to simply just take whatever x is, in this case 0 plus 1, which is 1. Now to do g of negative 5, that falls into the A function because it's less than negative 2. So I need to take negative 3 halves times x, which is negative 5, minus 1. This involves some fun math here because we've got some fractions, but that's okay. Negative 3 halves times negative 5 is 15 halves, or 15 over 2, minus 1, which is 2 over 2, gives me 13 over 2. Just a side note, I hope you're feeling comfortable with fractions. We're going to use a lot of them in Algebra 2 and higher level math, and you need to be comfortable with multiplying, dividing, adding, and subtracting fractions, getting common denominators. So if that's something you're not super comfortable with, please let me know because I can put you onto some videos that are really helpful to get those skills mastered. Back to our evaluating, we've now got g of 5, and I know that that is going to fall into the C portion of the piecewise. Now, this is an interesting one. There's no x to plug into. It's just 3, which means that no matter what x is, the answer is 3. So g of 5 is 3. Incidentally, g of 7 is also 3, and g of 24 is 3, and g of 100 is 3. Any number larger than 1 will be equal to 3. That's kind of a fun and interesting constant function there. All right, so we've got a piecewise here, but this time we don't have the function, we have the graph. We still have to figure out which of those 3 pieces this falls into. So just for fun, I'm going to label this part A, this part B, and this part C. Okay, so -2 falls into which one? Well, this is an interesting one because it doesn't fall into either of them. It's on the edge. Notice that -2 is where the 2 pieces kind of, I don't want to say connect because they don't connect, but where they one leaves off and the other takes up. So the question is, which one is it? Is it equal to 1 or is it equal to -1? Well, the closed circle means that it's equivalent and the open circle means that it's not equivalent. So in this case, the value of g of 2 is +1 because that's where the closed circle is. If we look at g of 1, that's over here, and we can just find that on the graph. That one's pretty easy. That's -4. And then g of 8 would be, now, you look at this, right, and you want to say 6, except that there's a hole, meaning that there's no value. It goes up to, but doesn't include 8. So this is a fun little symbol that means no solution or no value. It's called the null set. So we use that when there's not an answer that exists. In this case, because there's an open hole there, there's not an answer that exists. Okay? Go ahead and pause the video, see if you can do this one from the graph. We're going to find g of -2. So again, I just want to find -2 on the graph. And whoops, it is right here and right here. So I'm going to look for the closed circle. And I can see that that's the orange part, which means that this is equal to -2. Let's see, I want to find g of 2, which is on the blue section. And that looks like that is also equal to -2. So whether you're looking at a piecewise function or a piecewise graph, you should be able to evaluate it simply based on either the values that you see in the equation by figuring out, okay, is it greater than 0 or less than or equal to 0? Which category does that fall into? Or from the section of the graph where that x value exists. So hopefully you're feeling pretty confident about I can look at a graph of a piecewise and I can figure out where these values are, or I can look at an equation and I can figure out where these values are based on which section of the domain it falls into. Best of luck with your piecewise functions.